Good day everyone. We are Group 7 from BSI Training.
And our team members are John McTrinidad, John Patrick Pasco, Raisa Barawa, and Kit Angela Bayo.
In this presentation, we will demonstrate how to construct the three basic logic gates, AND, OR, and NOT, using a breadboard and integrated circuits.
These logic gates form the foundation of digital electronics. They are essential in circuits used in computers, processors, and digital systems. Today, we will explain how these gates work, build them physically, and verify their truth tables.
These are the materials we will be using: a breadboard for connecting components, and jumper wires for linking our circuits.
We have three integrated circuits: the IC7408 for AND gate, the IC7432 for OR gate, and IC7404 for NOT gate. Each IC contains multiple gates that we can use.
For our outputs, we will use LEDs along with 220 ohms resistor, which protect the LED from excessive current.
And finally, our power source is a 9-volt battery along with a battery connector. These components will allow us to properly build and test the circuits.
The first gate is the AND gate. This gate will only produce a high output if all of its inputs are high. The truth table is 0 and 0 equals to 0. 0 and 1 equals to 0. 1 and 0 equals to 0. 1 and 1 equals to 1. In simple terms, both conditions must be true before the output becomes true. We will use the 7408 IC, which contains 4 independent AND gates. Later, we will build one of them on the breadboard.
The next gate is the OR gate. The OR gate outputs 1 if at least one of its inputs is 1. The truth table is 0 or 0 is equals to 1, 0 or 1 is equal to 1, 1 or 0 is equal to 1, and 1 or 1 is equal to 1. This logic is commonly seen in many systems where one of multiple conditions can activate an output. The 7432 IC contains 4 OR gates, which allows us to test and demonstrate this behavior.
The last basic gate is the NOT gate, also known as an inverter. It outputs the opposite of the inputs. If the input is 0, the output becomes 1. If the input is 1, the output becomes 0. This behavior is important in digital system where signals need to be flipped or inverted. We will use the 7404 IC, which contains the 6 individual inverters that we can test. The last basic gate is the NOT gate, also known as an inverter. It outputs the opposite of the inputs. If the input is 0, the output becomes 1. If the input is 1, the output becomes 0. This behavior is important in digital system where signals need to be flipped or inverted. We will use the 7404 IC, which contains the 6 individual inverters that we can test.
Here's the 7404 IC. First, connect the Arduino's 5 volts to the breadboard rail and GND to the breadboard rail. Use solid jumpers. Now, connect pin 14 of the 7404 to the 5 volts rail. And pin 7 to the ground rail. For the input, connect pin 1 of the 7404 straight to 5 volts. For the output, connect a resistor from pin 2 to the long leg of the LED. Then use jumper wire to connect the short leg of the LED to ground.
And firstly, connect the 7408 IC to the breadboard. And then connect the Arduino's 5V to the breadboard's positive rail and the Arduino's ground to the negative rail. And then connect the IC's pin 7 to the negative rail and the IC's pin 14 to the negative rail. And now, connect a resistor to the pin 3 of the IC. And now to connect a LED, make sure the longer leg is connected to the other side of the resistor. And use a jumper wire to connect the shorter leg to the ground. And for the input, connect the IC's pin 1 straight to the 5 volts. And now, connect the IC's pin 2 to the ground. And lastly, connect the circuit to the power source.
This is the 7432 OR gate placed on the breadboard. Connect Arduino 5 volts to the breadboard's positive rail and Arduino GND to the negative rail. Using jumper wires, pin 14 is connected to 5 volts and pin 7 is connected to GND. Inputs on pin 1 and pin 2 are connected to either 5 volts or ground using jumper wires. Pin 3 goes through a resistor to the LED and the LED return to GND.
To test the 7404, I connect pin 1 to 5 volts and the LED stays off. Then I move pin 1 to GND and the LED turns on. This shows the NOT gate inverting the input.
If both wires set to negative, the LED will not turn on. And you will get the same results if you put just one wire into positive. But if you put two wires into positive, the LED will turn on. And that is how AND gate works.
With the both inputs at 0, the LED stays off. With 0 and 1, the LED turns on. With 1 and 0, the LED turns on. With the both inputs at 1, the LED also turns on.
These truth tables reflect propositional logic and represent P disconjunction Q, or is P conjunction Q, and not corresponds to negation P. This relationship shows how digital circuits are built from logical expressions.
This concludes our demonstration on constructing logic gates on a breadboard.
We have shown how AND or AND NOT gates work and how they can be tested using simple electronic components.
We hope this presentation helped deepen your understanding of basic digital logic.
Thank you for watching. This have been Group 7. Have a great day.